When we are solving these quadratic equations, which are the equations with an x squared in them, but not like an x to the third power, we're saying if we graphed these, we get a parabola, and then the question is, where does that parabola cross the x-axis? Those are our two solutions, and almost all the time we get two solutions. So, we would use what is called the quadratic formula to solve these when we don't have a problem that we could simplify to x squared equals some number like 36, or x minus 4 squared equals 36. If I saw one of those, I'd solve using square roots if I could. Or if I saw one with a 1x squared minus 5x plus something equals 0, I might look and see if I could factor that. The problem is not everything is actually factorable. If it's factorable, it means that these solutions, these x-intercepts, are going to be rational numbers, things that we could write as either integers or as fractions. Sometimes the answers are irrational, like it might cross the x-axis at the square root of 2 or something. So we have to have another way to solve these that we can get those irrational answers as well. Notice, and this is really important, first I get everything on one side of the equation and set it equal to 0. The a is always then the coefficient of the x squared term after everything's on the same side. The b is the coefficient of the x term, and the c is the constant. After I identify those, I plug them into this, which is the quadratic formula. So when I see a problem like this, the first thing I'm going to do is add 2 to both sides of the equation to get everything on the same side. And now I have negative 4x squared plus 1x plus 2. Some students are confused and they say, I can't add 2 to that side because there's nothing I can combine it with. I can add 2 to the left side, it's just going to be plus 2 on that side, so the constant kind of by itself. So a is the coefficient of the x squared term, which is negative 4, b is the coefficient of the x term, which is positive 1, and c is the constant, which is a positive 2. I'm going to now take those, and where I see a in this formula, I'm going to substitute negative 4. And where I see b in this formula, I'm going to substitute positive 1. And where I see the c in this formula, I'm going to substitute positive 2. The work I expect to see on this first step is only substitution. Don't calculate anything yet. Now this actually, some math teachers frankly read this incorrectly. They say negative b. The problem is then you think it's always a negative number there. This should be read the opposite of b. So x equals, well, if b is positive 1, then the opposite of b is negative 1. And I'm going to do this big fraction bar under this whole thing. And then plus or minus, which means that's going to be where it splits into two problems, one using the plus and one using the minus to get my two answers. The square root of, it says to take b, which is 1, and square it. So 1 squared. I went ahead and put that 1 in parentheses. Since it's positive 1, it doesn't matter, but if it was negative 1, you have to have the parentheses or it's just not right. Plus, then it says to take negative 4 times a times c. So negative 4 times the a is negative 4 as well, times the c is 2. Now that first negative 4 is going to be used every single time because it's part of the formula. And then over 2 times a, so 2 times negative 4. At this point, just go out to the side and say this is the square root of something. All we're going to do is take the calculator and punch in 1 squared plus negative 4 times negative 4 times 2 and see what you get. So if you punch in 1 squared times plus negative 4 times negative 4 times 2, you get 33 underneath the radical, which is that square root symbol. 33 is not a perfect square. 36 is, but 33 isn't. So at this point, your work should show that you split this into two problems. The x equals stays the same on both of them. Both of them are going to be over 2 times 4 is negative 8. Both of them are going to have the negative 1 at the beginning and the square root of 33. So far they look exactly the same. One of them, however, will use the plus between the negative 1 and the square root, and one will use the minus between the negative 1 and the square root. Now, when you punch this into your calculator, you punch in your -1 plus your square root of 33, hit equals, or it will be wrong, and then divide by your -8. If you don't hit the equals first, you're punching in -1 plus the square root of 33 divided by -8. And one of two things is going to happen. Either your calculator opens a parenthesis sometimes inside your square root symbol, and it's going to take 33 divided by -8 before it tries to do a square root, and it's going to give you an error, because you can't take the square root of a negative number. Or, even if it doesn't open this parenthesis, your calculator knows the order of operations, and it's going to divide the square root of 33 by -8 first, and then add it to the -1, which isn't what you want it to do. You want it to do this calculation, get an answer, and then divide by your -8. So be careful as you punch it in. If you punch it in correctly, make sure you practice this. This x equals 0.59, sorry, it's -0.59, and this x equals positive 0.84. So if I graph this parabola, what I know, if it was y equals -4x squared plus 1x plus 2, it opens down because the coefficient of the x squared is negative, and I'm saying this because in the next unit you got to know this stuff. It crosses the x-axis at -0.59 and positive 0.84, and then I also know if I put 0 in for x, this part becomes 0, this part becomes 0, and the y is 2. So the point 0,2, which is on the y-axis, is on this parabola, which means it crosses the y-axis at positive 2. Everything's on the same side of the equation here, so I don't need to rearrange it. Remember, there's a 1 in front of this x squared. So a is 1, because it's the coefficient of x squared. b is the coefficient of x, so positive 2. c is the constant, so positive 7. And I wrote the quadratic formula again to use. X equals huge fraction bar. Take the opposite of b, so the opposite of positive 2 is -2, plus or minus the square root of. Says to take b and square it, so 2 squared plus -4 times a times c. So -4 times 1 times 7, and then it says put all of that over 2a, so 2 times 1, because a is 1. Now when I punch this into my calculator, what's under the radical? 2 squared plus -4 times 1 times 7, I get a -24. Try to take the negative square root of -24 in your calculator, and if you do, you're going to get an error, because there's no real number that I could multiply by itself and get -24. Because a positive times itself is a positive, and a negative times itself is also a positive, so this one ends up being no real solution. So again, looking forward to the next unit plus this unit and saying what I know, if I were going to graph this thing, it never crosses the x-axis. It opens up because the coefficient of the x squared is positive. And if I put 0 in for x, I get 7 for y. So it crosses the y-axis at 7. It opens up, and it never crosses the x-axis and never touches it because there's no real solution. And this last one, I would add 2x squared to move it to the left because I want everything on the same side. And then subtract 5 to get rid of this positive 5. And that would leave me with 6x squared minus 2x minus 5 equals 0. So a is the coefficient of my x squared, which is 6. B is the coefficient of my x, which is -2. C is my constant, which is -5. At this point, I need to plug all of this into the quadratic formula. It says to take the opposite of b. b is -2, so the opposite of that is +2. Plus or minus the square root of, take b and square it, so -2 and square it. This is where you absolutely positively have to have these parentheses. If you don't have them on your work step, you will not receive full credit. I'm going to send you back to finish your homework. Most of your calculators, they know the difference. If you don't put this -2 inside parentheses in your calculator with the square on the outside, it's going to give you a different answer, because this, if your calculator is smart, isn't -2 times itself. This means to take the opposite of whatever 2 squared is. So 2 squared is 4, The opposite of that is negative 4, whereas this means to take the negative 2 and square it. So you have to have that written on your work step because it means something different. And then plus negative 4 times a, which is 6, times c, which is negative 5, all over 2 times a, which is 6. I'm just plugging into here. And then I'm going to see what is under that radical. If I take negative 2 squared, don't forget the negative 2 in parentheses with the square on the outside, plus negative 4 times 6 times 5, I get 124. Not a perfect square. I'm going to break this into my two equations. Again, each of them is going to be over 12, because 2 times 6 is 12. Each of them is going to start with 2. Each of them is going to have the square root of 124. But one is going to use this plus between the 2 and the square root, and one is going to use the minus. So I'm going to plug in 2 plus the square root of 124 equals, don't forget the equals, divided by 12 equals, and this x is 1.09. And then 2 minus the square root of 124 equals, divided by 12 equals, and this one is x equals negative 0.76. So again, looking forward to the next unit, what I know about the equation y equals this stuff. It opens up because the coefficient of the x squared is positive. It crosses the y-axis at negative 5. It crosses the x-axis at both positive 1.09 and at negative 0.76.